Alright, this is section 11.4. We're going to jump into rational exponents. Tonight's homework is page 679. Sean, have a seat there because they can't see. Sorry. Sean, they can't see. It's all good. We're going to do numbers 1 through 14. Let's review what's going to happen on tomorrow's opener. I'm going to give you something like f of x is equal to the cube root of x plus 5. And I'm going to ask you to identify its domain and range. The x-intercept and then the y-intercept. As a reminder, you find the x-intercept by plugging in 0 for y, and you guessed it, geniuses, you get the y-intercept by plugging in 0 for x. Take out your calculators, please. If I plug in 0 for x, I get 0 plus 5, and then take the cube root of that. Heidi, what do you get? I need you to focus on me, girl. Plug in 0 here. What's 0 plus 5? What's the cube root of 5? I don't know. You need a calculator. What's the cube root of 5? You guys need to find the button that looks like this. So there you go. So you press the 3, and then this button, and then the 5. Or the 5 and then the 3, depending on your calculator. Heidi, what'd you get, babe? I'm waiting for you. Let's go, let's go. What's the cube root of 5? Josh, do you have it? Mia, do you have it? Somebody have it? What is it, babe? Mia? Yep, 1.7. Heidi, did you get that? Now the x-intercept means that your y is equal to 0. So you're going to do 0 equals the cube root of x plus 5. So to solve for x, you're going to cube both sides. You get 0 equals x plus 5 because the cube root cubed, that's the whole point of the cube, is to get rid of the cube root. And now we subtract 5 on both sides. So x equals negative 5. God bless you. So my domain and range now, all I have to do is graph it and decide where my action is. So on the graphing calculator, and I have not decided yet if I'm going to let you use a graphing calculator, but for now let's graph it on here. I'm going to have the cube root, which is math button, down to cube root of x plus 5. I'm going to graph it, and then I'm going to decide where the action is. I don't see any breaking points in my domain. In other words, if I take a look at my graph here, I see action all the way across my domain. I don't see any asymptotes. I don't see any leaning towards a horizontal or vertical asymptote. So my domain is going to be all real numbers. So negative infinity to infinity. No, this is not where we're deciding it's a function. We're just deciding where is their action. Because there's no break in the domain. Now, how can you tell by the function? Is there a number that I'm not allowed to plug into a cube root? If you forgot, look back at your notes. We had the rules for the domain. If you look back, we said that the two rules for a domain are as follows. The denominators can't equal 0, and square roots cannot be negative. The square roots also include the 4th root, the 6th root, and the 8th root. Here, I am dealing with a cube root. So it does not fall into play for this cube root. Are cube roots allowed to be negative? I'm not sure. I think that we should try it. What is the cube root? What is the cube root of negative 8? Are we allowed to have a negative cube root? Wait, why not? What's negative 2 times negative 2 times negative 2? Negative 8. So why aren't we allowed to have a negative cube root? Are we allowed to have a negative cube root? Yes. The answer's right there. You're just not allowed to have a negative square root because a negative 2 times a negative 2 will never be a negative square root. But cube is fine. So answer me again. Are we allowed to have a negative cube root?
Yes.
Yeah. So that's why the domain is all real numbers, because you can plug in positive numbers, negative numbers. There's no denominator. So that's why the domain is whatever it wants to be. There's no restrictions here. Everybody with me? Now on tomorrow's quiz on the opener, I'm pretty sure I have a square root here. Now is your answer going to be different?
Yeah.
Yes, because it's not allowed to be negative. What would make this negative? Let's say this said square root. What would make this negative? Negative 5. Very good. Negative 5, and anything above a or below a negative 5 is not okay. Because negative 6, what happens if you plug in negative 6 here? Are you allowed to have that?
No.
Can you plug in a negative 7?
No.
Negative 8?
No.
So anything below a negative 5 is not possible. So then what would the domain for that one be? Negative 5 to infinity. That's the domain. All right, what about the range? How do you decide the range again, you guys? Go up and down the elevator? So how can we decide what our range is? So what I want us to think is outside the box, literally outside this box. Okay? So if I were to expand this, are there any floors on the elevator that would not be touched? Eventually. No, right? Literally, this thing is going to keep going and going and going and going and going. And I encourage you to go on Desmos tonight and play with these graphs and expand and watch how the graph never stops. So what would the range of this bad boy be? Negative infinity to infinity. When will the range change? What about if this is a square root? The square root is always what? The square root of any number? It has to be positive, right? How do you tell people that the answers all have to be positive? From what number and above? 0 to infinity. So you know the range for this bad boy is going to be 0 to infinity. You're never going to have a negative answer for a square root. For a cube root, you can have a negative answer. Are you convinced of that? You're allowed to take the cube root of a negative answer. You can do that. All right, and then the second question on the opener will be a composite function. Where I'm going to ask you to compose one function and the other. So I'll give you f of x is equal to 2 times x plus 1 squared, and then g of x is the square root of x over 2 minus 1, and I want you to prove that they're inverses. How do you prove that they're inverses? Plug F into G and G into F, and how can you check? If they're equal to X, but how can you check using a table? They should be switched, right? So remember what I suggested last week? I would do the what first? Make the table first so you know what your answer is going to be. So if the tables don't match, you already know that your composite proof isn't going to work. You guys with me? Don't do the other way around to confuse yourself. First do the table, then be like, oh yeah, they're inverses for sure. Then once you compose them, you know it should work. Everybody see? All right, once you guys do this with your group real quick, make a table for each one of these and decide if they're inverses or not. And see if the numbers are switched. Yes. Make a table. How many points do you need? 3 at the least. And then if you're not sure, do 4. And if you really want to be sure, put 5. All right, tonight's homework is rewriting them into rational exponents. You guys, I'm really happy you're helping each other out, but I don't want you guys to be lost, so shh. Pearson, come on. I know, I just don't want you to be behind. Hey, shh, listen, Lauren, I need you today. I don't know where you're at, but with me? All right, so we're going to be rewriting things today. So we're going to rewrite expressions now using exponents. Okay? So example 1. Let's say I want to write the cube root of x squared y as rational exponents. Anytime I have a cube root, that's the same thing as to the power of 1/3. If it's a 4th root, that would be a 1/4. If that's a 5th root, this would be a 1/5. Now you remember from Algebra 1, when you have a power to a power, you multiply the powers. So what you're going to do is you're going to say x squared times 1/3, and then that's going to be y to the 1/3. Well, 2 times 1/3 is 2/3. So my final answer here is x to the 2/3, y to the 1/3. Trust me, we're going to do plenty of examples so that you can catch on. Let's do another one. Example 2. Let's say I want to do the 5th root of x squared y cubed. Again, a 5th root means it's to the 1/5 power, so you're just going to rewrite x squared and y cubed to the 1/5. Then this 1/5 will basically, for a lack of a better word, be distributed to both powers. So it's the same thing as x squared to the 1/5 and then y cubed to the 1/5. Well, 2 times 1/5 is 2/5, so my answer is going to be x to the 2/5, y to the 3/5. So half of the homework, I'm going to give it to you as a radical, and you're going to write it for me as a rational exponent. The other half is I'm going to give it to you as a rational exponent, and you're going to write it as a radical. Let's do one more example, and then we'll do a doyo. Let's say I have the 3rd root of x plus y to the 5th. Well, this is the same thing as x plus y to the 5th to the 1/3. Remember, a third root is the same thing as to the 1/3 power. Let's pause real quick. Take out your calculators. I want you to do 100 to the 1/3 power. Tell me what you get. Stop staring at me. Please do that right now. Sorry. What's 100 to the 1/3 power? What'd you get, Daisy? Okay, I'll take it. Now do the cube root of 100. Oh my God, do you get the same thing?
Wait, oh, 3. I thought that was an equal sign.
Don't you get 4.6 both ways? So I learned that a third power and a cube root mean the same thing. So when I see this cube root, I'm not going to freak out. I'm just going to say, oh, it's the same thing as to the 1/3 power. It's the same thing. So I know a power to a power means I multiply. So my answer here is going to be x plus y to the 5/3. Here's your doyo.
Bless you.
Check your answers with each other, please.
X to 2/3, and then I got 8. I'm not done yet. Whole time.
I got like x squared over 8 4
Huh?
to the 1/3. I mean.
Yes! Let's go!
Oh, what'd you get? 4. Oh. Okay.
I got. Wait, why negative? I didn't give the negative.
Remember, if you have a exponent in the denominator, that's the same thing as writing it as a negative numerator. Both of these are correct, but on the test, if I have it written as a negative, you have to recognize that this means the same thing as this. So how come the x doesn't have a negative? Well, it wasn't in the denominator. These guys are in the denominator, so these guys are going to be negative, not this guy. So what you do need to recognize is, like, if you're speaking 2 languages, this means the same thing as this. But if I give you this answer on a test, you can't be like, oh, my answer is not there. Yes, it is. It's the same thing as this. Yes, honey. Yes, honey.
The denominator is always going to be a negative number.
If there's an exponent in the denominator, not the number, the exponent, then you make it negative. And this means the same thing as this. Questions on that? All right, example 4, and then we're going to go ahead and do a doyo and then start tonight's homework. If I give it to you in the opposite direction, let's say I give you a to the 3/2, b to the 1/4 over c to the 7/4. basically want to see what's going to be taken out of each one of these exponents and then change it up. So basically I need a least common multiple that multiplies into 3/2, 1/4, and 7/4. What I mean by that is, Lauren, I don't know what's going on today, girl, but I need you. So that means what I'm going to do is I'm going to figure out what was up here before I distributed it. And so I'm going to guess it's going to be a 1/4, and the reason why that's an educated guess is because 1/4 is the smallest one and can be taken out of each one of these. That means divided by 1/4. So what I'm going to do is I'm going to say this outside, God bless you, this outside bad boy was 1/4. So that means that I need to take whatever I had and divide it by 1/4. So on my calculator, what I'm going to be doing is 3/2 divided by 1/4, 1/4 divided by 1/4, and then 7/4 divided by 1/4. You will not need a calculator for this because you know how to multiply fractions. This is the same thing as 3/2 times 4/1. This is the same thing as 1/4 times 4, or 4/1. And this is the same thing as 7/4 times 4/1. So for here, these go away and you're left with just 7. So that this guy was a 7 then. This goes away and you're left with just 1. That means the B is just 1, but I'm not going to put a 1 there because it's understood as just. And then this one, this 4 and this 2 are going to reduce and you get a 2. 3 times 2, you get 6. So then this guy is going to be a 6. We're not done yet because this 1/4 can be written as the 4th root. So my final answer is going to be the 4th root of a to the 6th b over c to the 7th. And I'm going to make sure that that's extended out. How do you know you're done? When none of these are fractions. No fractions are left. If you take out a number and there's a fraction, what do you mean by take out a number? Remember how we divided everything by 1/4? If you divide by number and you don't get full numbers here, then you pick the wrong number here. The whole point is to get rid of, there's no fractions left here. Everybody see that? All right, try this doyo. Give me x to the 5/2, y to the 3/2, and z to the 1/2.
Oh, so I have to like that.
What did you guys take out of all of the exponents? 1/2, very good. So you know it's something to the 1/2. So you should have taken 5/2 divided by 1/2. You should have done 3/2 divided by 1/2. And then 1/2 divided by 1/2. This is going to be 5, this is going to be 3, and this is going to be 1. So my final answer here is x to the 5th, y cubed z. So my final answer, because of this 1/2, I have the square root of x to the 5th, y cubed z. Give me a summary, please.